Okay, answering question 4 finishes the activity. But I wanted to go on, and so here's the image of what's going on. This is even on the background of a graph, but I want to go on and make better graphs to visually see what's happening with these elevators. So the way that you visualize mathematics is to make graphs, look at graphs. And so the authors made this a little bit difficult in that they gave you expressions that were in terms of height. And so I wanted to put these graphs together where time is equal to 8/10 seconds per meter times the number of meters plus 16 seconds for elevator A, and for elevator B, it's a negative 8/10 seconds per meter times the number of meters plus 12 seconds for elevator B. But because this is written in terms of height, it's a little bit hard for me anyway, to explain and to understand. But here's one set of graphs where height is on the horizontal or the x-axis. So height is called the independent variable. You put in a certain number of meters, a height, and you figure out how much time it takes to get to that height. So time in this case is dependent. That goes on the y-axis or the vertical axis. So the time is dependent on the number of meters that you're looking at, the height. So height is independent. And then so this is hard to look at. It's hard to explain, a little bit difficult for me to understand. So then I rewrote the equations in terms of time. That looks like this. So over here, let's see where this is, right here. So height is equal to 1 1/4 meters per second times the number of seconds. So now time is independent. Time is on the horizontal axis or the x-axis. Time moves along. You go to a certain time and figure out where's the height of that elevator based on that time. So this is much easier for me to think about and to explain. And usually time is independent. Time moves along. There's nothing that changes it. And so in problems and in situations in physics and in math and science, usually time is graphed on the horizontal axis or the x-axis because time is usually viewed as being independent. You want to know what happens over time. So we're going to come back to these. I'm going to develop these graphs. This is going to take quite a bit of time. Remember, you could be done with this right now if you just stop with question number 4. All right, so let's go on. Let's take a look at what's going on with this. So look at elevator A. So first of all, positive meters above ground, negative meters below ground. Ground level is 0. And then time, a certain time of day. When you walk up to those elevators, that is time 0. I rewrote this slope-intercept form of the equation to remind you that this determines what the dependent variable is, or what's graphed on the vertical or y-axis. And this position identifies the independent variable, what's graphed on the horizontal or the x-axis. So you have a value for x, and you figure out what the value for y is. So y is dependent on whatever you choose for x. So for elevator A, time is dependent on the height. So notice that this height increases 1 meter as time increases 8/10 of a second. So this is the slope right here. So for every 1 meter, time increases 8/10 of a second. So that's not too bad. Time is increasing as height is increasing. But actually, let's go back for just a second. So this is elevator A. So elevator A is going up. The height is increasing over time. As time increases, actually as height increases, time increases. Now look what happens with elevator B because the expression is written in terms of height. So as the height increases 1 meter, so that's what this slope says. For every meter, time is going to decrease 8/10 of a second. Well, that means that time is going backwards. So that's weird already. This is the first example of something that's odd in looking at this equation written this way. So time is going backwards as height increases. So that makes sense. As you increase the height here, as you go from ground level to 1 meter, that's less time for this elevator to reach that point. As height increases even more, that's less time for this elevator to reach that height because the elevator is decreasing in height. As you increase the time over here, as you increase the height over here, so you go to 1 meter, that's more time it takes this elevator. It's going to pass ground level and it's going to go to 1 meter, 2 meters, 3 meters, 4 meters, 5 meters. It's going to go past ground level. Remember, it takes 16 seconds in this case to get to ground level, and then there's added time for it to get to whatever the height is if height is positive. Now, if you rewrite each equation in terms of height, so now height is equal to 1.25 meters per second times time. So I'm rewriting it, I'm rewriting this equation in terms of time. So now we're going to make time the independent variable. So notice what happens as time increases. So all I did is I took this equation up here and I rearranged the terms so you end up with height equals a certain amount of time plus a negative 20. This elevator is located at a negative 20 meters when you walk up to the elevator. So what that means is that as time increases, as this number gets bigger, what's happening to the height? Well, this whole term is increasing, and that means that you're taking a larger positive value and adding it to a constant negative 20. So this expression is getting more and more positive over time. So the height increases as the time increases. This is tough stuff. But notice what happens if you rearrange the equation for elevator B. So now as time increases, what happens to this term? So as time increases, this term gets more and more negative. So it's a larger magnitude of negative values. This is hard to say, but the time is getting more and more negative. This term is getting more and more negative as time moves forward, and you're adding a more and more negative value to a positive 15. So that means this whole expression is getting more negative as time increases. So as time increases, the height decreases. So as time increases, this elevator is going down. As time increases, this elevator is going up. So this is tough stuff. It's hard to explain. Okay, so let's look at this on a graph. So if we graph these two equations, so this is the equation for elevator A. So if you just start graphing it without thinking about it too much, the y-intercept is at 16 seconds. It's right here. And notice once again that height is on the horizontal or x-axis and time is on the vertical or y-axis. So the y-intercept is 16 seconds, and this is going to go up 0.8 of a second for each meter. So you go forward 1 meter, goes up 0.8 of a second. Forward 1 meter, up 0.8 of a second. Now this is forward 2 meters, up 1 6/10 seconds. 2 meters, 1 6/10 seconds. Now you could get away with graphing this just by graphing 3 points. This point here at 16 seconds for the y-intercept, and then go out here to 10 meters. So 10 times 0.8 is 8, and 8 plus 16 is 24. So this point is right on the grid, so that makes it easy to graph. And a negative 10 meters, so a negative 10 times 0.8 is a negative 8, plus 16 is 8. So you go out here to negative 10 meters, and that's going to be at 8 seconds. And then you just connect those 3 points. You really only need the 3 points to draw the line. Same with elevator B. You really only need these 3 points. The y-intercept is at 12 seconds. And then in this case, 1 meter out, 1 meter up is a negative 0.8 seconds. 2 meters, another 0.8 seconds. And this is 2 meters, a negative 1 6/10 seconds, but you only need these 3 points to graph it. So if you go out to 10 meters, 10 times the negative 8 tenths is a negative 8. 12 plus negative 8 is 4. So it's this point right here. And a negative 10 times a negative 8 tenths is positive 8. And positive 8 plus 12 is 20. So this point right here, this point, and this point. You only need those 3 points to graph it. All right, so let's take a look at what's going on. Here's the equation to figure out the height. So we're going to figure out this point right here using the equation, and we're going to figure out this point right here. So this is negative 20 meters, and this is positive 15 meters. So if we just extended the lines, you'd see that they go through those points on the x-axis, but let's confirm that using the math, using the algebra. So this is the key right here, I think, in trying to explain this. This term right here has to be negative 16. So negative 8 tenths times whatever height that is has to equal negative 16 seconds. And then you're going to add that to a positive 16 seconds. That's going to get you to time 0. So now you go through the calculation and you find out that that height right here is negative 20 meters. For elevator B, it's the same idea. I skipped a line here. I should have put this line in here. But this term right here has to be negative 12. So it's a negative 8 tenths times h equals this positive 12 would go over to the other side of the equal sign and would equal negative 12. And then I just multiplied through by negative 1 to reverse the signs of this expression and this expression. But the key is that this has to be negative 12 at some point in time, because negative 12 plus positive 12 equals 0. So now you go through the calculation and you find out that that is at 15 meters. This is going to be negative 12 when that height is a positive 15 meters. So the time is negative. It's a negative 12 seconds when the height is a positive 15 meters. So let's see what that means. Let's look at the graph. This is the same calculation. So 15 meters. All right. So to get to time 0, we have to go backwards in time 12 seconds. So we're going to go to negative 12 seconds. So what's happening to the elevator as you go backwards in time 12 seconds? Well, that elevator used to be at ground level. So it used to be right here. This is ground level, negative 12 seconds. And it takes that 12 seconds. So now you're going to go backwards. This is a negative 12 seconds. And now you're going to go forwards to get to 15 meters at time 0. So this is the negative 12 seconds to get this elevator back to here. And now you have to go forward 12 seconds to get the elevator to be 15 meters above ground. And so now that elevator is 15 meters above ground, and it is 12 seconds away from you. So now it's going to take another 12 seconds to get that elevator back to ground level. So this is hard to visualize, hard to think about. We did this before, but now it's on a graph. For elevator A, to get to negative 20 meters, remember this term right here has to equal negative 16 right here. So now we're going to go backwards in time 16 seconds. Whereas elevator A, 16 seconds before you show up. And then we're going to go forward in time 16 seconds. So we're right here at time 0. So now let's go backwards in time 16 seconds. I should have drawn these lines in here. But this elevator is going back up to ground level, and it takes, so 16 seconds before you showed up, this elevator was at ground level. So you're going to go back 16 seconds, and now we're going to go forward 16 seconds. So what's happening to this elevator is as you go forward 16 seconds before you show up, it is traveling away from you to negative 20 meters. So it's going down to negative 20 meters before you show up. And when you show up, it is 20 meters away from you into the ground. It's at a negative 20 meters, and it is also 16 seconds away from you because it took 16 seconds to get to that negative 20 meters. And so now you press the button. It's going to take 16 seconds to reach you at ground level at time 0. After time 0, sorry. So you press the button after time 0. it's going to take 16 seconds to return to ground level. Okay, so we just figured out the location of each elevator, elevator A and elevator B, at time 0, the moment that you walk up to those elevator doors. So where are they located? Elevator A is at a negative 20 meters, and elevator B is at a positive 15 meters above ground. Elevator A is below ground, negative 20 meters. So now you press that button, and how long is it going to take for each elevator to reach you at ground level? So this is really after this time. So you press the button, how long is it going to take for that elevator to get to you? So you walk up to the elevators, press the button, how long does each elevator take to reach the ground floor? Well, elevator B, pretty simple calculation here. The height is 0, ground floor, so this just goes away. This becomes 0, and you're left with 12 seconds. Elevator A, the height is 0, so this becomes 0, 8/10 times 0 is 0. So you're left with these 16 seconds. So let's take a look at this on the graph. So elevator A is at a negative 20 meters. It's going to take these 16 seconds to reach you at ground floor. So you press the button. So this is time going forward. And it's going to take these 16 seconds to get to you. So negative 20 meters, it's going up, and time's going forward. Finally, 16 seconds later, that elevator is at ground level. Elevator B is at 15 meters when you walk up, and now it's going down. So notice that this height is getting less over time. So the time is going forward. You're standing there waiting for the elevator, and this is getting to it's descending, it's going down. So 14 meters, 12, 10, 8, 6, 4, 2, and it finally reaches you at time, after time 0. It finally reaches you in 12 seconds. So this is the time after you press the button. 12 seconds, this elevator has gone down 15 meters to reach you. Okay, so now we know the position of each elevator when you walk up to those elevator doors. One elevator is at a negative 20 meters, and another elevator, the other elevator, is at a positive 15 meters, and we know how long it takes to get to ground level after you press that button. Elevator A takes 16 seconds, elevator B takes 12 seconds. So when do they pass each other? At some point in time, they will pass each other. They will be at the same height, and that's going to take the same amount of time to get there. So the way to figure that out is to take each expression, the expression for elevator A, this is time. Time equals this amount. And this is time for elevator B. Time equals this expression. So if you make those two times equal to each other, they travel at the same time, when will they be at the same height? When they've traveled the same amount of time, when will they be at the same height? So you figure out what that height is. So you go through the calculation, and you get a height of a negative 2.5 meters. So if you look at the graph, so I'm going to go through the same calculation again right here. So you work through the calculation, and you get a height of a negative 2.5 meters. So that is right here. So notice elevator A is going up. It's ascending. It's going up, 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 up. Hasn't quite reached ground level yet, but elevator B is descending. It's gone past ground level. So this is after it's gone past ground level. So now it's going down below ground, and this is before elevator A reaches ground level. So it's still below ground, and that height is a negative 2.5 meters. Now you can use either expression to figure out how long it takes. So you can use either the expression for elevator A, just replace height with a negative 2.5 meters, and notice that this is a negative 2 seconds. And elevator B, replace height with a negative 2.5 meters. This is a positive 2 seconds. So what that's showing you right here is this is 16 seconds, and this is 2 seconds before that 16 seconds. So this is a time of 14 seconds. And for elevator B, this is 2 seconds after it travels the 12 seconds. So after it's reached ground level. So this is 14 seconds. So that's what the graph shows you once again. So this elevator is going down, 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 down. It takes 12 seconds to get to ground level from when you have pressed the button. There's the 12 seconds, but then it keeps on going. Elevator A is going up, 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 up. It takes 16 seconds after you press the button, but before that time, it passes elevator B, and that takes a total time of 14 seconds. Notice that's halfway in between the amount of time it takes elevator A to get to ground level, that's 16 seconds, and the amount of time it takes elevator B to get to ground level, that's 12 seconds. So halfway in between, that's 14 seconds. That's when they pass each other. When does each elevator reach a certain level, a certain height? You could choose any height and say, how long is it going to take elevator A to get there? How long is it going to take elevator B to get there? So in this case, they chose 14 meters below ground. So the height is negative 14 meters. So how long is it going to take elevator A to get to negative 14 meters? And how long is it going to take elevator B to get to negative 14 meters? Now notice, before you even start on this, that elevator A is at negative 20 meters. So it's really pretty close. Elevator B is at a positive 15 meters. So that's pretty far away. So you can look at this and kind of figure out that the math is going to show you that it's going to get, elevator A is going to get to negative 14 meters first. So you take this equation and now you plug in the height, negative 14 meters. And you want to figure out how long is it going to take to get there. And it will take, so you work through the math, it will take 4 8/10 seconds. So let's look at the graph and see if that makes sense. So look at the graph. It takes 4 8/10 seconds to get to negative 14 meters. So this is elevator A. Its height is negative 14, which is right here. So it's going from negative 20 meters to negative 14 meters. And how long does that take? It takes 4 8/10 seconds. Now there's a couple ways to look at that. One is to realize that the rate at which the elevator A is traveling is 8/10 seconds per meter. And if it's 6 meters, so from negative 20 meters to negative 14 meters is 6 meters, 6 times 8/10 is 4 8/10 seconds. So it's going to take this 4 8/10 seconds. Another way to look at this is that what is this 11 2/10 seconds right here, this negative 11 2/10 seconds? That's how long it takes either elevator to travel 14 meters. And this is a negative 14 meters, so it's traveling, it takes 11 2/10 seconds to travel that 14 meters, but it's negative because it's almost as if you can look at this time from negative 20 meters to ground level, that's 16 seconds. But this elevator doesn't have to travel that entire 16 seconds. It only has to travel for these 4 8/10 seconds. So you can take the 16 seconds and subtract the 11 2/10 seconds, and what do you end up with? Just this travel time of 4 8/10 seconds. A little bit harder to look at it that way, but that's a way to look at it to compare it to elevator B. So for elevator, here's a little diagram. So notice that elevator A is at negative 20 meters. It only has to travel 6 meters to negative 14 meters. That takes 4 8/10 seconds. But look at elevator B. Elevator B is at a positive 15 meters. It has to travel this 23 2/10 seconds. It has to travel 15 meters plus another 14 meters. That's a total of 29 meters. So that all that time is going to take 23 2/10 seconds. We're going to do that math right now. So if you plug in negative 14 meters, how long does it take to travel? It takes 11 2/10 seconds. But this is a positive 11 2/10 seconds. And that time gets added on to the first 12 seconds. It takes 12 seconds to get to ground level and another 11 2/10 seconds to get to a negative 14 meters. So on the graph, elevator B is starting out at 15 meters. It's going down, 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 down as time goes forward. Finally, it reaches ground level at 12 seconds. But then to get to negative 14 meters, it has to travel another 11 2/10 seconds. So that gets added on for a total of 23 2/10 seconds. Now notice that this 11 2/10 seconds from here to here, that's 11 2/10 seconds that doesn't get added on to the 16, actually gets subtracted from the 16 seconds. And that's the same time from this 12 seconds to here to 23 2/10 seconds. So that 11 2/10 seconds gets added on to 12 seconds. This 11 2/10 seconds gets subtracted from this 16 seconds because you're only going to here. So again, here's the 15 meters, takes 12 seconds to get to ground level, and another 11 2/10 seconds to get to negative 14 meters. Elevator A doesn't have to travel this 11 2/10 seconds. So that can get subtracted from the 16 seconds, and you end up back at 4 8/10 seconds. Another way to look at these graphs and this problem is to separate out the proportional part of this relationship, which is 8/10 seconds per meter times the number of meters, from the actual linear relationship of the elevator, which has this additional 16 seconds. So this is the proportional relationship right here. So here's the beginning relationship with the additional 16 seconds. So at a negative 20 meters, it is 16 seconds away from you. So to get to ground level, it has to travel for 16 seconds to get from a negative 20 meters to ground level. But if you look at the proportional part of this relationship, just the 8/10 seconds per meter times the number of meters, that goes through 0, 0. That is a proportional relationship. If you double the height, if you go from 4 to 8, then the amount of time is going to double. It's going to go from about, looks like about 3 to about 6. That is a proportional relationship. If you double the height, the time's going to double. If you triple the height, the time's going to triple. So just look at just this relationship for a moment. So this means that it was at ground level when you showed up at the elevators. So time 0, elevators are at ground level. That means it was traveling up, 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 and then the time that you walk up to the elevators is traveling to ground level. So before that time, so negative 20 meters below ground level, it took 16 meters. It took 16 seconds. That was 16 seconds before you showed up. And so now it's traveling towards you as you're walking up to the elevator. So this is time before you got to the elevators. And then it arrives at ground level as you arrive at the elevators and press that button. The elevator doors open immediately because the elevators are at ground level. But that's not what happened. What happened was the elevator was at a negative 20 meters when you walked up to the elevators. So how long does it take to get to the graph of this elevator? So negative 20 meters at time 0, it takes these 16 seconds. So now notice you have to add these 16 seconds every single time because it is 16 seconds behind. It's starting out at negative 20 meters to get to any level. It's not starting out at 0, starting out at negative 20 meters, so you have to add these 16 seconds each time. So if it's at 0 time, if it's at ground level, you have to add these 16 seconds that it takes the elevator to travel to ground level. So now what happens when it's at negative 14 meters? If it were a proportional relationship, if it were at ground level at time 0, it would take 11 2/10 seconds before you showed up to be at negative 14 meters. But it's not. It's starting out at negative 20 meters. So it takes this extra 16 seconds to travel to this negative 14 meters. So that means you have to add these 16 seconds to this time, this negative 11 2/10 seconds. So for you, if the elevator is at negative 20 meters, it's going to take this 4 8/10 seconds to get to negative 14 meters. The point is that you have to continually add the 16 seconds because you started out behind. You started out at negative 20 meters not at 0. It's the same thing for elevator B. If you started out at 0, then elevator B is traveling down, 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 down as it goes this way. So this is negative height as time goes forward. So 12 seconds before you show up for the proportional part of this relationship, just negative 0.8 seconds per meter, it's going to be 15 meters above ground because it's going down, and right as you show up for the proportional part, right as you show up, it's 15 meters above ground, and it's going to take another 12 seconds to get to you as you walk up to the elevator. So imagine you're walking up to the elevator. This elevator is going down, 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 and it finally gets to ground level as you walk up. That took these 12 seconds right here, because it was at negative 12 seconds. I'm sorry, it was at 15 meters 12 seconds before you showed up. All right, so now you always have to add these 12 seconds to the time because it's always starting out 12 seconds behind, because it has to travel these extra 15 meters because it's 15 meters above ground. So to get to, let's look at this just for a second. As you show up, the elevator is 15 meters above ground, so it took 12 seconds to get to that 15 meters above ground. So that's adding the 12 right here. So what about what happens at negative 14 meters? So if you go out here to negative 14 meters, if the elevator was at ground level as you showed up, it would take 11 2/10 seconds for that elevator to travel back down, to negative 14 meters. So it's this time right here, this 11 2/10 seconds. But it's not starting at ground level. It's starting 15 meters above ground. It's starting here. So you have to add these extra 12 seconds to get the time that it takes for this elevator to get to negative 14 meters, because it has to travel these extra 15 meters and then another negative 14 meters. So that takes 11 2/10 seconds plus that additional 12 seconds that the elevator was behind. So that gets you to a negative 14 meters in 23 2/10 seconds. I want to go through one more set of graphs where I have switched the axes. Now this is the set that we just looked at. So the height is graphed on the horizontal axis, and that's the independent variable. So you put into the equation a height, and you want to know what time the elevators are at given that height. So this is height on the x-axis or the horizontal axis, and time is on the y-axis or the vertical axis. So time is dependent on height in these graphs. But what if you switch them? What if you graph them so that time is independent? Time is usually the independent variable once again. So time is moving along, and so at what time, or given a time, what is the height of the elevators at that given time? So 4 seconds, 12 seconds, elevator B is at ground level, 16 seconds, elevator A is at ground level, and so on. So you go through a little bit of math and look at the axes when there's what happens when there's the graphs when the axes are switched. Now, I rewrote the problem so that if a student was going to look at these equations, these expressions, and rewrite them as equations equal to height, this is height is equal to 1 1/4 meters per second times the number of seconds plus a negative 20 meters. Remember, elevator A starts at a negative 20 meters. Elevator B starts at a positive 15 meters. But this is a negative 1 1/4 meters per second times the amount of time. So now it's easier to see that elevator B is going down because this is a negative height per time, and this is a positive height per time for elevator A. And you go through, I rewrote each of these questions so that if you're going to graph these equations, you'd graph them with time on the time on the horizontal or x-axis, and height is dependent on that time. So how do we get to those equations? So I took the original equations and I just rewrote them so that you want to get the height equal to some amount of time. Given a time, what's that height? So what you do is you just move all of these terms over to one side and then height over to the left side so that height is by itself. So in this case, add negative 16 to both sides to move that 16 over here. So now you have time plus a negative 16 equals 8/10 h, height. And I'm going to rewrite the 8/10 as 4/5. So this is how you do that right here. 8/10 is the same as 4/5. Easier to work with this fraction if you don't have a calculator, and you shouldn't always use a calculator. Try to do it without a calculator and think of, in this case, about fifths. All right, so you have time plus a negative 16 equals 4/5 the height. And so now you have to multiply by 5/4. The multiplicative inverse of 4/5 is 5/4. You have to remember to multiply both these terms. So this is the distributive property. So 5/4 times the time and 5/4 times this negative 16. And remember, that's a negative 16 seconds that we're talking about there. And so 5/4 times the time plus 5/4 times, and I rewrote negative 16 as a negative 4 times 4, so that I can cancel out this 4 in the denominator with this 4 as a factor of 16. And you're left with a negative 4 times 5, that's negative 20. So 5/4 times the time plus negative 20 equals the height. And just rewrite it so that the height is on the left side. And 5/4 is 1 1/4, or 1 1/4. So you have 4/4 plus 1/4. 4/4 is 1. 1/4 is the same as 25/100. So height is 1 25/100 times the time plus negative 20. And this is in the form now of y equals mx plus b, where time is the x variable. It's going to be graphed on the x-axis or the horizontal axis, and height is going to be graphed on the vertical axis or the y-axis. So one last time, actually not a last time, but one more time. Time is the independent variable. Height is the dependent variable. Height is dependent on the amount of time that you plug into the equation. Same thing with elevator B. So I'm going to go through, move the positive 12 over to the other side. It's negative 12. Add negative 12 to both sides. Multiply by a negative 5/4. Remember to distribute that between both the time and the negative 12 seconds. Rewrite negative 12 here as a negative 3 times 4. These 4's cancel. You're left with a negative 5 times negative 3. So that's the opposite of 5 times negative 3. The opposite of negative 15 is positive 15. You're left with this equation here. And again, it's in this form, y equals mx plus b. So some summary comments. So these equations are now written in terms of time. So here's time here as the x variable that's graphed along the x-axis. It is independent, so time moves forward independently of the height, and the height is dependent on that time. So height is graphed on the y-axis, or it's the dependent variable. So the height of the elevators depends on the time. Time moves forward independently. So what does that look like on the graphs? So here's time on the x or horizontal axis. Here's height on the vertical or y-axis. Height is in meters. Time is in seconds. And notice that the height, each grid line is 2 meters. So it's 2, 4, 6, 8. So you have to think about that as you use the slope to graph these. So here are the two equations. Elevator A, height is equal to 1 1/4 meters per second times the amount of time plus negative 20. And elevator B, height is equal to negative 1 1/4 meters per second times the time plus a positive 15. So that means that for elevator A, negative 20 is the y-intercept. So height of a negative 20 is where it crosses the y-axis. That's time 0. So already this is a little bit easier for me to see what's going on. So at time 0, the height is negative 20, and the height goes up 1¼ meters for every second. So you go forward 1 second, it goes up 1¼ meters. Forward 1 second, up 1¼ meters. Forward 2 seconds, up 2½ meters. That might be a little bit easier to graph. 2½ Anyway, so you get out here to when the height is 0 meters. So this is the height of 0 meters right here. What time is it when that height is 0 meters? So it's going from negative 20 up here to 0. Well, if you replace height with 0 and you calculate what time is, you're going to end up with time equal to 16 seconds. So time is equal to 4/5 of 20. You think about that, 4/5 of 20. Take 20 divided by 5. 20 divided by 5 is 4, and 4 of those 4s, 4 times 4 is equal to 16. So that's this 16 seconds right here. You really only need these 2 points, the 16 seconds and the negative 20 meters, to draw this line. And draw that line. And so that is the graph of this equation right here. So elevator B, the graph of this equation for elevator B, the height goes to the y-axis at positive 15 meters. So right here, positive 15 meters. So for this graph, I only use those 2 points. So if you replace height with 0 meters, so what is the time when the height is 0 meters? So this elevator B is going down, 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 down. Again, it's easier for me to see that when the axes are labeled and used in this way, as time on the horizontal axis and height on the vertical axis. So the height of elevator B is going down. If you replace height with 0 meters, you're going to calculate this through, and you're going to end up with 5/4 of the time is equal to 15. So 4/5 of 15, what does that equal? We'll take 15 divided by 5. 15 divided by 5 is 3. And 4 of those 3's is 4/5. 4 times 3 is 12. So at height 0 meters, ground floor, it takes elevator B 12 seconds to get there. That's this 12 seconds right here. This is the calculation to figure out when these 2 elevators are at the same height. When do they pass each other as elevator B descends and as elevator A ascends, goes up? So you can see in this case, you can see that the difference in height at the beginning is 35 meters. So it's a negative 20 here and a positive 15 here. You add those 2 absolute values together. This length is 35 meters. And every second, this gap closes 2½ meters. This is a negative 1¼ meters. It's right here, a negative 1¼ meters per second. And this is a positive 1¼ meters per second. And that's right here, 1¼ meters for every second this goes up. So you combine those 2, this gap closes 2½ meters every second. So if you have 35 meters as the gap, how long does it take to close that gap at a rate of 2½ meters every second? Well, you divide by 2½. Elevators are 35 meters apart, moving closer at 2½ meters each second. So it takes 14 seconds. That is 35 divided by 2½. So it's going to take 14 seconds for these 2 elevators to meet. And so what level will they be at when they meet? Well, first of all, to do this math, rather than look at this and calculate this through reasoning about the 35 meters and the 2½ meters per second, you can just set these 2 equations equal to each other and calculate the time that it takes, because this height is equal to this expression and this height is equal to this expression for elevator B. When are those 2 heights equal? At what time are those 2 heights equal? So you solve for time, and notice that you're doing the same thing as you solve. you're figuring out that this gap closes at 2.5 meters every second. So that's this 2.5 meters every second. That's that 2.5 meters every second right there, because it's combining this slope, 1.25 meters per second, with this slope. This is adding another 1.25 meters per second. So you get the 2.5 meters per second, and you combine this length. This is negative 20. That absolute value of 20 plus 15, that adds up to 35. So here's the negative 20. You take that negative 20, add a positive 20 to both sides. So 15 plus 20 is 35. So it's the same thing as reasoning through this. This is the 35 meters. Divide by this 2.5. That's going to tell you that this time is going to be 14 seconds. So dividing by 2.5 is the same as multiplying by 2/5 right here. So this is 5 halves. Divide 35 by 5 halves. That's the same as 35 times 2/5. And this makes this calculation a little bit easier. 35 divided by 5 is 7. 2 times 7 is 14. Now to get this, so it's 14 seconds. To get this height, you can use that 14 seconds in either one of these expressions. Either this expression on the left or this expression on the right. So if you use the expression on the left, so in 14 seconds, what's the height? So height is equal to, after 14 seconds, multiply through, you're going to get 7.5 meters plus negative 20. So it's a negative 20 meters for elevator A to go from its height, negative 20, to ground level. But when they pass, this elevator only has to travel 17.5 meters. That's 17.5 right there. So plus the negative 20. So it's this negative 20 plus 17.5. That gets that elevator to a negative 2.5 meters. This elevator travels down 17.5 meters to the point where they're at the same level. Well, that's 2.5 meters past the 15 meters it takes to get to ground level. Now again, you can use either equation. You end up at 2.5 meters below ground. So this is showing you with each equation. So you replace time with 14 seconds. And I'm just simplifying this a little bit, factoring this out. These two 2's cancel out. You're left with 5 times 7 is 35 divided by 2. 35 divided by 2, that's this entire length, 35 meters, divided in half. Half for elevator A is 17.5 meters going up, beginning at negative 20 meters. So it's going to end at negative 2.5 meters. And this is the same 17.5 meters, but this is 17.5 meters going down because this is a negative 1.25 meters per second. These 2's cancel out. This is a negative 35 divided by 2, and it gives you a negative 17.5 meters. So it goes up 15 meters. So now it has to go down that 15 meters, but it has to go 2.5 meters further. So it goes up 15 meters, and then you subtract a total of 17.5 meters, or add a negative 17.5 meters to go down, and it's going to go down 2.5 meters past ground level. Okay, so the amount of time that it takes each elevator to reach a height of negative 14 meters. So right here, negative 14 meters. Now remember, the reason I'm doing this, I'm re-graphing each problem with time on the horizontal axis and height on the vertical axis, is that it's much easier for me to see what's going on in the problem. It's a little bit easier for me to explain. So to get to negative 14 meters from a negative 20 meters, this is elevator A. Elevator A only has to go up these 6 meters. That's easier for me to see in this case. So up 6 meters, how much time does that take? That's this 4 8/10 seconds right here. And I'm going to go through the calculation in just a moment. But for elevator B, to get to a negative 14 meters, it has to go down 15 meters to this point right here, and another 14 meters to this point right here. And that takes a whole lot of time. Now with time on the horizontal axis, it's just easier to see for me to see that time is moving forward. So here's just 4 8/10 seconds, and out here it's 23 2/10 seconds. A lot longer time. for elevator B to get to negative 14 meters. So the calculation for elevator A, again, it's just easier for me to see what's going on. This height is negative 14 meters. So I'm going to add to this negative 14 meters a positive 20 meters. That's this 20 meters to get up to ground level. So I'm going to add that, and that tells me that this length is really only 6 meters. It has to go up to 6 meters right here, and the amount of time that it takes is 5/4 some amount of time equals 6. So what that means is, so this is a number that's less than 6. So 5/4 of a number less than 6 is going to raise that value to 6. So this time is going to now be 4/5 of that 6. Well, 4/5 of 6 is 24/5. 4 times 6 is 24. And you divide out 24/5. Divide 20 by 5. That's 4. And you're left with 4/5. So 20 divided by 5 is 4. And 4/5. And 4/5 is the same as 8/10. So this is 4 and 8/10 is the time. This time right here. For elevator B, this calculation, again, you take the 15 meters, and now as you subtract 15 or add a negative 15 to this side, it's adding a negative 15 to this side, so you get a total of a negative 29 meters now. Over here, it's a total of 6 meters to go up. It's a total of 29 meters to go down. And this is a negative 5/4 meters per second. So now when you multiply, you're going to multiply by the multiplicative inverse, a negative 4/5. So a negative 4/5 times this negative 29 here. Well, negative times a negative is a positive, so you can rewrite this as 4/5 times a positive 29. And I rewrote 29 as 30 minus 1, so I can do this calculation in my head. So that means that it's going to be 4/5 of 30, 4/5 of 30 minus 4/5. This 4/5 times this 1 right here. Well, 4/5 of 30, take 30 divided by 5. 30 divided by 5 is 6. And 4 of those 6's, each 6 is 1/5. You only need 4 of them. So 4 times 6 is 24 minus 4/5. 4/5, that's going to give you 23 and 1/5. So you take away 4/5 from this 24, you're left with 23 and 1/5. And 1/5 is the same as 2/10. So the amount of time it takes is 23 and 2/10 seconds to get from 15 meters above ground to 14 meters below ground.